I'm Thomas Nyman, the MajorTim.space 2022 to 2023 STEM for Him Young Ambassador, and I am age 12.
And I'm Tom Jones, the MajorTim.space Honorary Young Ambassador, and I'm age 11.
Well, I guess I better introduce myself. I'm Matthew Tosh. I'm a pyrotechnician, presenter, safety advisor, and trainer. I do a lot of teaching as well.
Okay, so to start off with, what do you like doing most out of all the different things you do?
Oh, that's a difficult question to go in with. To start with, I genuinely enjoy everything that I do, and I have this what we call a very varied portfolio. And the reason I say that is I take things from different areas and apply them to elsewhere. So, for example, when I first became a presenter, I was doing television presenting. And when you're presenting, you really need to understand what journey the audience is going on, what you're trying to communicate. So I need to understand who I'm talking to. And sometimes that presenting was done pre-recorded, so we would record it in a studio. Sometimes it was done live. And of course, if you do anything live, you've only got one opportunity to get it right. You could do your rehearsals beforehand, but when you're actually doing any live presenting, that's the thing that the audience experiences at that moment. Now, when we do firework displays, I can rehearse with different fireworks, but the firework display itself has only got one opportunity to work. I've only got one opportunity to get it right. So the mindset, the way of thinking that we had to apply when I was doing television work, I can apply that to my firework displays, and it means that I become very meticulous. You know, my attention to detail when setting up firework displays with my crew is really detailed, it's really focused, because in the back of my mind all the time, just as with television presenting, I know that I've only got that one opportunity for the audience to experience that show. Does that make sense?
Yeah.
So I enjoy all of it really, and but that's an example of where I take skills from one area and can apply them to something almost completely different.
Yeah.
How has health and safety changed over the years that you've been involved with pyrotechnics?
The health and safety itself, the approach for me has changed as a kind of individual, but the health and safety is more of a process. It's about how you think. So you find a problem. So, for example, if you're given a contract maybe to do fireworks off the top of a building, and then you have to think, well, what do we need to do in order to make that safe, to make sure that that show can happen safely? And so the conversation is about what do we need to put in place. So you might need to close a road, for example. If the building is very tall, really high, then you may need to close quite a few roads, because as things fall down, if they're falling down at an angle, they're going to go even further on the ground. And if we're going really high in the sky, we may need to look at what we have to do in the air. Do we need to close in the airspace? Are there any aircraft nearby? So there's lots of things like that. And the reason I mentioned that is my first introduction to health and safety was way before I did fireworks. I used to be a science teacher, and some of the people I was working with would say, "Oh, we're not allowed to do that." I'd come up with an idea of something I wanted to do as a demonstration or a science experiment, and a lot of people were telling me, "You can't. We're not allowed to do that. You can't do this. You can't do that." And I kind of had this idea that health and safety was really quite restrictive. But when I started at fireworks, and the more I've got into fireworks, I've actually learned that health and safety is about, if you get it right, it enables you to do things rather than not do things.
Yeah. So way back, when you were younger, what started your interest in science?
Oh, I was one of those, my parents would probably look back and say I was quite an annoying child, because I was always wanting to find out how things worked, sometimes by destroying them or breaking them. So my dad was very good. My dad was an electrician, and he was very good at showing me, the inside of radios and things like that. And I was just fascinated that you've got all these little bits of circuitry and colourful things that I first thought were like sweets. Some of these colourful things were resistors or capacitors. They were all the components that made it work. And I just thought this was amazing. And he gave me these old radios, and I would take them to bits, and then I would try and put them back together again. Of course, I've destroyed them. They wouldn't always work. And then he, I think out of frustration, him and Mum decided to buy me an electronics kit, and I would build things, and I built little circuits that would do things, and I built my very own radio that I could tune, and a little earpiece that I put in, like a little earbud, and it was terrible quality. It was really crackly, but I built something that worked. I thought, wow, you can do this. So by understanding how things work, you can actually make other things. And that was it. I was always encouraged to ask those questions and explore. And then as I went through school, I had some very inspirational teachers who would give me that space to explore, and they would allow me to explore. And it's kind of grown from there, really. So really, it's genuine curiosity about how the world works.
Yeah.
What's your favourite display you've seen or done?
You talk about firework displays?
Yeah.
Oh, my favourite display, I have to say, probably one of the really special ones. I was involved back in 2012. So that was probably year, you wouldn't have been very old then. Would you have been born by then, 2012?
Yeah.
Yeah. So I was involved in fireworks for the Olympic torch relay that went around the UK. And it came through my city where I live, Bristol, and we were asked to do a surprise firework display, but in the daytime. Now, we have a very famous bridge in Bristol. It's called the Clifton Suspension Bridge, and it goes over the River Avon. And the torch relay was going to run across there, and they were going to do a kiss. They would hand it over. So where one runner would come along, they'd meet in the middle, pass the baton on, and the next runner would carry on. So we had to do this top secret display to surprise everybody in the daytime. So we had to do a night shift. We couldn't tell anybody about it. I couldn't tell my friends. They just knew because the reason I said that, some of them wanted to go out for a meal the night before. They said, Matthew, are you available? And I had to make an excuse, but I couldn't tell them what I was doing. And we met at 10 o'clock, all the crew. We had a secret meeting just outside Bristol to agree who was going to be doing what. And then we travelled to the bridge, and the bridge was completely sealed off. It was closed. The army had sent sniffer dogs along to make sure that it was safe. Nobody had planted anything that was potentially going to be do some damage. And the police had sealed it all off. And we were allowed to work on this bridge from midnight through till about 6 o'clock in the morning. Then we had to go and hide. And then all the excitement, people arriving, they weren't allowed on the bridge, and they didn't know why, but they were allowed to congregate in the sort of surrounding areas. And I was tasked with pressing the button. So at 8:30, when the Olympic torch came across, the police and lots of cameras and everything were coming through, the excitement was building, helicopters overhead. I had a little earpiece in, and the radio command came, fire. And I pressed go on the computer, and I was monitoring the firing, and it was incredibly exciting because it was broadcast live. Lots of my friends saw it, and then they realised why I wasn't available. So it was really special to do something like that.
Yeah. So do you think drones will eventually completely replace fireworks due to the fact that they are environmentally friendly?
Well, it depends what you mean by environmentally friendly. No is the first answer. I don't think they will completely replace fireworks. I think there is a place for them, just as there is with lasers and lights. I think they work really well together. And if you want a really silent, spectacular display of light moving around, then drones are most definitely the thing to go for. But the reason, one of the reasons that people find fireworks attractive is that it's the magic. You're actually working with fire, and there's also a physical thing that you experience. Now, fire is very important in many different cultures and religions going back thousands of years. Human beings have been fascinated by fire because we know it's dangerous. we can know it can also be very useful and provide us safety and security. We can use it to defend ourselves. And there are lots of gods in different religions that fire relates to, or fire is the symbol of those gods. And if you think about some of the festivals that happen throughout the year, Chinese New Year is built around fireworks and loud bangs to ward off evil spirits and welcome in the new year and bring good fortune to people. Diwali, the Hindu festival of light, is another one where they celebrate with fireworks and sparklers as well. So if we said no fireworks completely, it could be very difficult for people wanting to mark those religions. But also there's a very physical experience that you get when you go and see a firework display. When you hear the loud bangs, you're actually feeling some of the vibrations, and that for the audiences makes it very exciting. Now, having said that, we do need to think as an industry about how we reduce our impact on the environment, and that's a very difficult one to solve. And working with other technologies like drones is one way of doing it. So what you're not doing is replacing fireworks completely, but you're reducing the quantity of fireworks that you're burning in a display. So I think we will potentially see people thinking about the size of displays, the quantity of fireworks going in, but I don't think we'll lose them completely. Now, behind the scenes, there's a lot of work going on at a research level about the ingredients that are used in fireworks, the actual chemicals that are burning. Are there ways that we can burn chemicals that will reduce the particulates that form in the atmosphere, which can cause some of the problems? So that's a really interesting area of experience. And certainly people of your generation will be those future scientists who could be coming up with some of those solutions.
How different are fireworks? And by that I mean, how do some make a bang and others fizz and so on?
Okay, yeah, so different types of fireworks. To get a bang, what we do is we take a fuel and we confine it when it burns. So firework fuels, the compositions, the ingredients that go into fireworks, they all obey this very strange rule that if you burn them loosely in the open air, so if I take some gunpowder and I put it on a board and I ignite it, it will burn really rapidly, really quickly, but it will just like that, and all the heat and the energy will go into the surroundings. Now, gunpowder is a mixture of fuel and something called an oxidizer. An oxidizer provides oxygen to a fuel and helps it burn. So the gunpowder has got everything that it needs. If we confine that material, so we take gunpowder and we put it into maybe wrapped up in a bit of paper, when we ignite it, it actually burns very, very quickly. And that's because as it burns, the oxidizer heats up and makes oxygen that feeds into the fuel, and so it's got everything that it needs. The stronger the container I put it in, as that fuel burns really rapidly, pressure builds up, and so what you find is the pressure builds until the container bursts, and it releases a huge amount of pressure in a very short amount of time, and that we hear and detect as a bang. So that's how we make a bang. We confine our materials and they in a container, and as it burns, it ruptures and bursts, and we get a bang. For colours, we use different metals, metal salts, and that is because the atoms that make up metals have got particles in their building blocks called electrons. Electrons absorb energy from the heat of a chemical reaction. Now, different size metals, different types of metals have different size atoms and different numbers of electrons, and so they can absorb different amounts of energy. But what happens when they absorb that energy, they get into what we call an excited state. And this is, if you go off and study chemistry or physics, you'll learn about excited electrons, and it's quite an unusual term. But when they're excited, they're slightly unstable, and they actually want to lose their energy and get into their relaxed ground state. Because in science, things that are unstable, they don't exist for very long. And what happens, as they get back into their ground state, they release energy. And we can see that energy as light. And the upshot is different size atoms of metal give us different colours of light. So that's how we make coloured fireworks. So we talked about bangs and colours there. In terms of crackles and fizzes, well, some fizzing can be done by putting gas through a very tiny hole. So a rocket will fizz. That's because you've got rapid moving gas going through a tiny little hole. It's a bit like if you whistle, but if you change the shape of your mouth, you can almost make a sort of whooshing kind of fizzing noise. And crackles are very small amounts of rapidly burning fuel, just little nuggets. That's probably the best way to describe it.
Yeah. So how do you dispose of fireworks? Like after you've used them and everything?
Right. Okay. So there are two possibilities. Three actually. Sometimes fireworks they're not used and they go beyond their use by date, and so they're just no good. You wouldn't use them on a display because they might not work or they could malfunction. So they go onto a disposal pile at the factory and the stores where they're kept. They may then meet fireworks from a show that have not gone off for whatever reason. They may, you light a firework and it hasn't gone off. Ooh, we douse that with water and we remove it from sight. And what happens to all of these fireworks is they get sent into a controlled burn. And the way you do that is you dig a very large pit and you build up walls either side of the pit, and you put your fireworks in that you want to dispose. You put a very long fuse into that pit and you burn it. But because it's got really high walls on, it controls the burn. So these are done in remote locations, way away from any houses. And if anything then goes off or explodes, it goes upwards. So it's a controlled industrial burn. It's a very messy process, but that's how they do it. So they're the two circumstances where you dispose of fireworks.
Yeah.
Well, what elements are used in fireworks?
Oh, right. Goodness me. Well, we've talked a little bit about it already, haven't we? We mentioned gunpowder. So in gunpowder, there are three ingredients, two of which are elements. So you've got, well, actually, that's a slight lie. One of the ingredients is charcoal. The main ingredient in charcoal is carbon. Then there's sulfur, and then there's something called potassium nitrate. Potassium nitrate is made up of three elements bound together: potassium, nitrogen, and oxygen. Elsewhere in fireworks, we use a lot of metals, and we're using things like magnesium. That gives us a bright white color. We use strontium to give us red. Calcium gives us a sort of reddish orange. What else do we use? Sodium, that gives us yellow. Barium gives us green. Boron also gives us green. That's a non-metal. We're trying to use more boron than barium. It's slightly better for health. And we've also got things like copper, that gives us a sort of blue color, and or potassium, I've already mentioned. Okay, lithium as well, that gives us sort of like a purplish red.
Yeah.
So there's lots.
So yeah, what do you hope to accomplish in the future?
Oh my goodness. I want to keep the variety going. I want to keep the variety of my work. I'm not just about fireworks. Fireworks is part of my career, and it's the big thing that people see. But I do a lot of work behind the scenes on events. So I've just come back from the Cheltenham Science Festival doing health and safety. So making sure that people can enjoy a festival safely. So all of the thinking that I've learnt in firework displays, I can use in other events to help people put on events really safely. So I want to help people put on safe experiences for audiences. I really enjoy giving audiences that experience. So whether they're at a firework display that I'm firing, whether they're at a festival or a stage show where I'm working behind the scenes, nothing to do with fireworks, or I'm presenting a radio show or doing something on a video for an audience. That's what I really enjoy doing, and that's what I want to carry on doing.
Yeah.
How do you get the fireworks to go off at different heights?
They usually, it's to do with the size of the tube that they come out of. A lot of fireworks are fired out of tubes, and the bigger the firework, the larger the diameter of the tube, the higher it's got to go, because as it bursts in the sky, its diameter will be bigger. So we need to get it up higher in order to keep it safe. So we use more black powder in the tube. so more fuel to fire it out, and they're fired like cannons. So the larger fireworks have a larger amount of gunpowder in the bottom of the tube to fire them out, and we call it the lift charge. So the larger the firework, the higher it goes, and it's important to get the different heights as well, because it creates layers in the sky. If everything went just to the same bit of the sky, it'd be really dull.
Yeah. So fireworks can cause health problems for us. For example, breathing difficulties and lung problems. So what safety precautions, if any, do you take to keep yourself safe while working with fireworks?
Yeah, it's a really good question, and it's a really important one that some people overlook because they think, oh, I love the smell of fireworks. But if you're doing fireworks all the time, as a key part of your job, those little particulates can build up, and it's not good to breathe any fumes, really. Smoke's not good for us. We know that as human beings. So for people working on fireworks sites, it depends where you're on the world. In the UK, what we try and do is fire our shows electrically, and we fire the shows with the wind blowing away from the audience and blowing away from the people operating the show. Firstly, because of our health, but also if we disappear in smoke, we can't see what's going on. You know, it's our job to make sure the show stays safe. So if we disappear in a cloud of smoke, we can't see what's going on. We have no idea if it's staying safe. So that's one of the ways of doing it. Now, if I'm working indoors with stage pyro, then I need to make sure that the venue is well ventilated. Otherwise, everybody will disappear in smoke. That's one way of doing it. But also looking at the types of fireworks that we fire. Some shows, they want a lot of smoke because they may be using lights and things, and they want to show beams, you know, in the smoke. But other places we don't want a lot of smoke, so we'll look at different fuels that burn more, a bit more smokeless fuels. So things like nitrocellulose, that's a smokeless fuel. That's very good for indoor fountains and things. So it's a combination of looking at the types of fireworks we'd use and also the ventilation.
Yeah.
So how are fireworks in a large display coordinated?
You have somebody designs a show first of all, in the same way they design a light show, and they say what movements they want and what they want to appear in different parts of the sky. But to actually time it, we use a computerized firing system, which will trigger lots of little electric matches. They're igniters. We call them igniters, but they're essentially little electric matches on the end of a wire, and it's a very thin piece of wire at the end of it with a fuel around it. And the thin piece of wire gets hot when you send the current through it. So when we send the current through, it ignites and creates a spark. Now, I wire that into a control box, which is controlled by a computer, and this control box or a module, we've got lots of these all over a firework display site. And then at my master computer, my master firing system, we can say, right, module 1, I want you to fire circuit 3. Module 2, I want you to fire circuit 8. And the computer's got a clock running, and we write a code, a script. So there's lots of coding involved. We write a program that says, you know, at 31.5 seconds, module 8 is going to fire circuit 16. And when the program gets to that bit, that's what happens. And of course, if we want really complicated, fast-moving sequences, we might be firing things every 10th of a second or every 100th of a second. So there's lots of individual firing commands.
Yeah.
Okay.
Mm-hmm. So what did you do during the pandemic when no firework displays or events were able to take place?
Well, because I have other work that I do, I switched to other work. So I did quite a bit of teaching, helping people to become better presenters, because a lot of the world found themselves having to talk on Zoom and Teams and platforms like we're using today. And that was unusual for people. But for people who have done television work, that's normal. That's what we do. So I did a bit of teaching about how to become better presenters on camera. But I also got quite a bit of health and safety work, because if you remember, there was a lot of talk about keeping people safe. And when people wanted to start putting events together or seeing if an event could possibly take place, they were having conversations with people like me, about how that could happen, and that's what I did. So I was very fortunate that I could find some other work. It wasn't as much work as I would normally do, and it was very difficult, and I lost a lot of my live shows, but they weren't completely lost. They were paused, and so they just got shunted a couple of years later.
Yeah.
In shows, they have like little sparks. How do they work?
Oh, sparks are made by burning little pieces of metal, little fragments of metal. So we use things like magnesium or iron, and you'll actually see this in school when you have your science lessons with Bunsen burners. And when you study metals, your teachers may show you iron filings or iron powder being sprinkled into a flame, and the powder melts, or the little flakes melt, and then they react with the oxygen in the air. But when they do that, sometimes they form little bubbles that burst, and that's what the little flittering thing is. So metal sparks, metal fragments creates the sparks that you see.
Yeah. So what advice would you give to young people who are interested in pursuing a career in pyrotechnics?
All right. Okay. Well, first of all, you do need to be very good at science. Not necessarily about the detail of the subject, but it's the skills that you get. Because in the science subjects, you're taught about analysing things, observing, listening, watching. Okay, and that's exactly what I need to do whenever I'm firing a firework display, because it's a live thing, and I'm taking in information all the time, watching what's going on, and I have to make decisions based on that. So a lot of the skills that I use in my work came directly from my science and also my maths lessons, because maths teaches you to focus. You've got a problem in maths, you get your teeth into it. I've got to fix this, and you shut out everything else whilst you focus. When I'm working on a firework display and I'm firing the show, I have to shut out the noise of the event and the audience. So the audience can be going absolutely crazy and bouncing in a field, and it's really exhilarating, but I have to filter that out because I'm there to do a job. It's really strange. So those are the first things. And then if you are interested, get yourself off to go and watch some firework displays, go and learn about them. There's lots of stuff on YouTube going behind the scenes, and people like me who do explanations, seek those people out and follow them on social media and see what they're up to. And then when you are 18 is the magic age at the moment, you can approach a firework company and ask and tell them that you're interested, and they may agree for you to go and have a look around a display site, and that starts the conversation. Okay?
Yeah.
So it's about starting that conversation, and if they see that you're keen, then they may take you on. They may offer to train you up. Who knows?
So thank you for taking your time to do that with us. It's been an honour talking to you, and it's been fun.
Well, I thoroughly enjoyed it as well.
Yeah, it's been really fun.
Same thing with me, a big thanks, and I really like talking about fireworks, so I might have a look into it.
Yeah, absolutely. And also, just I would say, once you do start exploring it, some people do start exploring it and then decide once they get into it, well, actually, it's not what I really want to do. And that's okay. It's okay if you start at something and you learn during the process, oh, that's not for me. Better to learn early on than further down the line, isn't it? Because then you might say, oh, well, I'm going to try something else instead. But whatever you end up doing with your futures, good luck.
Thanks.
Thank you.